Go ahead.
Very good afternoon, ladies and gentlemen, for our webinar number 14 today
13,
from
13,
W
sorry.
13. Sorry, my bad. It's a 13 is the luckiest number today. If COVID is lucky, 13 is lucky. Like super. Let's change the avatar. Let's change the karmas. This is Amit Malhotra, joined by Ahad. Uh, so far, so good. We promised you kind of with half heart that no more webinars for a while. We've kind of gonna take a break for a bit. We've like bammed, but 12,000 registrants over the last few weeks of webinars. So I think we've done our bit in terms of what we call it stay informed quarantine edition. We will be quarantined now for a while. So we'll see how this new evolution goes. I pass it now to Ahad to take the event forward. From WFM Media, we will come back for sure. We'll just give you a break for a bit. We will be there forever and we have interesting webinars. We have Galen, who's already up at 4 o'clock in the morning in the United States, so he looks fresh. I hope he's had 3 cups of coffee already. And Shaon, Ahad, over to you, my friend.
Right. Thank you so much. So welcome to this 13th edition of the WFM Media webinar series. So today's webinar is on designing with high performance dynamic and smart glass. So we have two interesting presenters. Our first presenter is a well-respected architect. Her name is Shaon Sengupta. She's the director at Edifice Consultants. She's going to be talking about high performance glass design in buildings. She's going to give an overview of glass and building efficiency, climatological considerations in designing of glass envelopes, and building orientation defining fenestrations. She is a well-respected personality in the architecture field. Sorry about my mobile. She's been with Edifice right from the inception, from 2000, and she's been leading zonal and the north and eastern operations of the firm. Her specialty is also energy projects and sustainability. So that's going to be interesting to hear from her. Our next presenter is Galen Burrell. He is the director of lighting at View. He's presenting from Denver, Colorado, in the US today. It's 4 a.m. in the morning over there. So thank you so much, Galen, for taking time out at this odd time to present today. So he's representing View. View is a dynamic glass company based out of the United States, and he's going to be talking about designing for optimal comfort and space color with smart windows. He's a celebrated lighting consultant. He's been at Arup for many years before joining View last year, and he was also awarded the 40 under 40 for the International Lighting Designers Award in 2008. These are our two presenters for today. I'll get straight into the agenda. So Shaon is going to go first, followed by Galen, and then we'll have a joint Q&A. Let me now pass the control to Shaon. She will be presenting first. Shaon, over to you. You must have got a pop-up on your screen to share your. Galen, you and me will switch off our cameras and we'll come back later once Shaon is done. Don't fall asleep. Right, perfect. Go ahead, Shaon.
So hi, everybody. I'm Shaon, and I've been asked to speak about glass and high-performance glass in buildings, and also how glass affects buildings and how makes the buildings, so to say, as high-performance envelopes. So what I'm going to do is that I'm going to talk about 3 projects of ours and cover the various aspects of using glass, how to use glass, where to use glass, what kind of glass to be used, and how best to make use of this particular building material to the best requirements of each project typology. So essentially, why do we use anyways glass in a building, right? Yeah, obviously we use it as an envelope to a habitable space, which allows visibility and light, doors, windows, facades. It's also an aesthetic element. We also use it as an insulation material, and we use glass extensively to make masses look delicate and invisible. Now, what are the considerations while fulfilling these purposes of using glass in a building? what do we really need to keep in mind when we start using glass all over the place? Of course, human well-being, because the spaces that you are building are for human well-being. We have to look at climate and environment. We have to look at efficiencies of the building. We have to look at costs and ease of construction. So while there are many other factors, these are few of the important factors that one needs to consider while using glass in a building. Now, when we do use glass and in a building, and we look at efficiencies of glass, climatological considerations obviously kind of overruled most other factors while using glass envelopes. And when we look at climatological considerations, building orientations then becoming the the defining factor for the various fenestrations that the openings that we make in a building. To explain these aspects, I'm going to touch upon three projects that Edifice is doing currently, and how these various design principles have been applied real time on these projects.
Are you able to change the slide?
Net is a little slow, so do I have controls to change the slide?
Yeah, of course. You will have to change it at your end. Just click the right arrow, the next. Okay, just go down right on.
Yeah, it's working.
That's working. Oh, good.
So the first project is a net zero energy project. It's the ministry headquarters for the Ministry of New and Renewable Energy. The building is called the Atal Akshay Urja Bhavan project. It's a project in Delhi on Lodi Road, and that's a view of the south side of the building. It's about a 4 lakh square foot project with a few basements, ground, and 8 floors above. It stops working. Okay, so this particular project, since it's for the Ministry of New and Renewable Energy, the mandate that was given to us that it would be a sustainable project, obviously, but it also would be a net zero energy project. Now, when we say a net zero energy project, what do we mean? We mean that we would be generating that amount of energy within the project that we are actually using over a period of a year. So in this particular project, because the size of the plot area was about 2.7, 2.8 acres, we only had the roof surface that we could use. So as you can see in the image, we have extended the roof further ahead of the building footprint. And when I get to the layouts, you'll get to know more. However, we've used a lot of solar apart from the roof on the southern surface as well. Now that's a glimpse of the layout. As you can see on the right hand side, the plot is like an L, an inverted L, and it's like you have an entry which is like a sliver of an entry, and the larger, fatter arm of the L is what you get as a layout space for the building. So you have a road going around the building, and that's a longish building that you see, which is like a straight edge kind of a building. Now, when we looked at the planning principles, if you see the north arrow that is there, I'm not sure whether you can see my cursor, but the bottom right hand side, you can see the north sign given. So this is a north-south oriented building. Now, when you get a north-south oriented building, what happens is that you have a very long eastern and western facade. While you may want a long eastern facade for daylight to come in, a long western facade is something which is not good for a project at all. So I look at the planning principles on how we kind of mitigated this disadvantage of having a very long western facade. And we had a short edge on the north and a short edge on the south. So essentially what we did was that we have taken all the services along the western edge, so that we have all the usable area on the eastern side, and we get an extent of complete daylight coming in through the day for the usable areas of the floor plate. And what we essentially then get is that we are able to reduce the lighting load for the building. And by taking all the services, in the sense of services, the transit cores, the lift lobbies, the washrooms, the various air handling units, fire exit staircases, etc., all along the western edge. So these are areas which do not require daylight, and they act as a buffer and an insulation to your rest of the usable space of the floor plate. Okay, now about the project, we have, in terms of net zero, we have a requirement of generating 12 lakhs kilowatt hour of energy for the project to run, for it to be able to become net zero. By virtue of the solar panels that we have on the roof, we are able to generate 15 lakhs units, which means we are actually energy positive. Now, obviously, to become an energy positive building, there are certain planning principles that have been taken into consideration. We have a complete insulation on the western wall, as I said, and wherever there is no glazing, we have taken double insulated wall with insulation between the brick wall as a double brick wall. We've taken radiant cooling as a cooling methodology, in addition to a normal high efficiency maglev chiller, so that we are able to bring down heat load in the building considerably. In terms of massing and orientation, of course, I've just touched upon the point that how we have tried to mitigate the orientation of the building by bringing in glazing on the east wall and blocking off the western wall completely. By employing these various active and passive design methodologies, we are able to utilize 30 to 40% lesser energy than a conventional building. So when you start working on a building, you obviously do a SWOT analysis. And if you see the top right-hand side diagram that I was mentioning, that you have a north-south oriented building, which means that we are having a lot of heat gain from the western facade of the plot. So we did a wind analysis, and we did a sun path climatic study. And as we all know, the west side, south side, and to some extent the eastern side, you can see the left-hand side diagram that shows the areas from where the building is getting radiation, the building is getting heat gain. So how did we go about doing the orientation of the building to mitigate this? First of all, we have a very longish plot. So the distance is quite high for a person to walk from one end to the other. So obviously we've kind of divided into two parts. There is a top half and a bottom half. So there's a northern half and a southern half. And the transit cores have then been put in the middle. So you enter the building from the middle of the long edge, and then you either go to the right or the left. What you can see here is what I've just explained on how we have taken the, it's almost like a wall that we have created of various services areas and utility areas to reduce heat gain from the western side. But what we have also done is that we have then, if you see the right-hand side building, a right-hand side diagram, we've actually tried to split the wall, the western wall, into certain apertures, so that we are able to bring in some amount of light and wind into certain usable areas. That's the layout finally. So you enter from the bottom, the east side of the plot, which is a sliver of a plot area, and then you move to the right. You have the auditorium right in the beginning. So you have multiple entries to the building. So you have a public zone, which is the exhibition space at the rear, and the auditorium. When you move further to the right, the circle that you see, that's the main entrance area. That's That's the entrance, which is actually splitting the building into two parts, the northern half and the southern half. That's the detailed layout of the building. Here you can kind of see the kind of utilities that have been taken on the northern edge, and the eastern wall is completely glass. It's of course a high efficiency glass with a U value of 1.1, but this being the eastern facade, we want to, and we have taken in entire natural light into the floor plate, and the plot has actually helped us in getting a thinner floor plate, which also means that we are able to get in humongous amount of natural light into all the usable spaces. While we all know in India that in government projects, and this being a ministry headquarters for the Ministry of New and Renewable Energy, typically the officers want enclosed spaces and enclosed buildings, but we and private spaces which are walled with opaque partitions. But we were able to convince the client, and we were able to impress upon them the advantages of getting natural light into a building, and the internal partitions have then been designed in complete glazing, so that beyond the cabins also, which are all along the eastern edge of the building, the light is actually going right through deep into the floor plate till you hit the blank walls of the services. So in that manner, we've been able to bring down the lighting load of the building considerably, while we are also trying to bring down the heat load factor on the western and the southern edges. The southern edge is not a big concern because it's a very small edge, and the solar panels on the southern side is also acting like a buffer, so there is no direct sunlight falling on the southern wall of the building. These are some of the images. So the top right hand side, you can see the wall section on how we've taken a double wall with an insulation in the middle. The bottom right image shows the solar panel on the roof and the southern edge. So then we went on to do a lot of software driven building simulation to see that. So as you can see in the layout, the oranges and yellows is where the daylight comes in, and the blues or the dark colored areas are areas where natural light is not coming in, where we've designed the areas which do not require natural light, so to say. Moving on to the views, you can see the eastern glazing facade there, and we've got full blown into doing full glass on the eastern facade, while we've tried to block off the other edges where we could take glass. We've gone completely into it, and these are of course DGUs with high efficiency. This is the southern wall that you see. Again, another view of the southern wall, and you now start seeing the western edge. So that's the complete western wall. So these green verticals that you see are actually wind flow areas. So there are a lot of areas in the building to bring down energy load where we've taken non-air conditioned areas. Now to bring in comfort during the summers, what we've done is we've created these glass walls, and we've given apertures for the wind to move into the building. And of course, there's going to be drip irrigation. So these act like in northern India, we know how these cheeks work, which are moist, and they bring in cool moist air to cool down areas. So that's the fundamental that is being used on the western on the areas which are along the western wall. That's the eastern edge of the building, where you can see that we've taken complete glazing in the building. And the roof that you see cantilevering out is essentially brought out so much so as to maximize the footprint area of the solar roof on top. So the key to net zero on a net positive energy building is twofold. One is you should be able to generate as much as energy possible from various sources, and you should also be able to reduce the consumption of the building. So both these also, only when you reduce the required energy load of a building, will you be able to generate only that much to be able to become net zero? I'll move on to another very interesting building, which is a full-blown glass building. While we've also taken, radiant cooling, etc., like the previous project in this building, but we've gone a plumb with using glazing all around. So this is a much smaller building. This is about 1 lakh square foot with 3 basements, a ground and 11 story. So when we move into the, of course, again, building orientation is something which needs to be considered when you start off building design. So the various factors were taken into consideration. These 3 images that you see on screen are planning principles. So the last image is on the screen is the orientation and the sliced floor plate that we have taken. So the client essentially wanted an iconic building to showcase. This building is in Ahmedabad, and it is a corporate office for Monte Carlo. And while the first 2 images you see are the various other ways of going ahead with the footprint, the reason we've taken the zoning 3, the last right-hand side images, because we are able to, by virtue of slicing the front facade, we are able to create a very long facade and give a very long edge to the road. So the viewing angle is increased, the viewing mass is increased, and you will see how we have addressed this particular glazing to bring about the iconicity of the building. So of course, Gujarat and Ahmedabad, it's a very colorful state, and it's the diamond center of the country. So we looked at diamond being the concept while we designed the facade, the main facade for the building. And you can see at the bottom right hand side how the module of the diamond was worked out, and the central diagonal of each of these diamond shaped glazing panels was then pushed up to create a 3-dimensional panel, and then 4 of these panels were joined together again to create another larger diamond shaped panel. Now I have moved to the layout. It's a rendered layout, so I don't know whether people are able to see the layout as yet. So I'll hold on for maybe 2-3 seconds. But essentially, what we have done is that we have a north entry, and the eastern edge of the building is what you see is the diamond paneled edge. When you come into the site, you are welcomed by a triangular portion in a double height area, which is the reception. And when you walk into the reception also has a glazing on top of the on the ceiling, so that through the glazing of the ceiling you are able to see the entire eastern edge of the diamond paneled facade. So that is a double height area. As you can see, the number 8 which is there crossed out, that's the double height reception area. When I get to the views, you will be able to better understand what I'm talking about. So from the first floor onwards, beyond the first floor, from the second floor onwards, the building recedes. The triangular shaped reception ends at the first floor level, and the chamfered edge of the building continues. So this image actually shows the various shading coefficients and simulations that were done to be able to understand how these diamond shaped facade elements are responding to the climatological factors. Because while it is the eastern facade, there is a distinct amount of heat gain from the east as well. And when you are creating a diamond edge, you will realize that you are creating a northeast and a southeast. So you're actually creating 2 facades within one diamond, which is not like an east-east. One of them is a northeast facade and one of them is a southeast facade. So when we did the simulation, if you can see the irradiation analysis of the facade done, I'm not sure whether the screen has still come up. But if you can see the screen, you will see these orange verticals are the areas where the heat gain is maximum. And that is the reason for that is that while it is the eastern facade of the entire building, it also, these facades are also facing towards the south, which is why the southern side of the heat gain for these panels are being reflected in this analysis, in this study. So we worked out various ways of trying to mitigate this southeast edge of the building. We looked at fritting it. We looked at shading it in various ways. We looked at colored glass on the southeast side of each of these panels. But finally, we went ahead with a particular type of glass, which is called the sage glass. And in the western and the northern facade. And for these diamond panels, we took a very high efficiency SKN 144 glass, and we took a DGU so that we were able to mitigate the heat gain from the southeast side. So as you see here, we looked at, making in option 1, the southeast edge, we've tried to make it opaque, and only the northeast edge we've tried to take it as clear. We also looked at ceramic fritting as couple of options, shaded ceramic fritting where the heat gain is happening more. We would have a darker frit, and slowly the frit becomes lesser. The reason I'm showing all of this is these are various ways of tackling usage of glass and various treatments that can be done to glass so that you're able to use this building product in a more efficient and more appropriate manner, obviously based on the location and orientation of the side of the building where you're using this material. So that's a view of the building. So that's the eastern view of the building. You can see the diamond panels that have come up there. The right hand side image on the screen, if it's still come up, is the western facade. So what we did is we've used a particular kind of glass called sage glass, which is provided now by the vendors in India as well. The peculiarity of this glass is that of course, it is an electrical signaled glass, and you have to give an electrical signal to each of these glass panels, and they automatically become translucent based on the signals that they receive. So obviously the gradations are 30, 60, 90. So it goes on to like a 1% translucency as well. So Saint-Gobain provides this particular glass in India, and we use this in the western facade because we did not want to compromise in the morning hours the views, and the look and feel of the interiors. We wanted the early morning sunlight to come into the usable areas, and what sage glass actually gives us is that from afternoon onwards it starts blocking of the western sun. So while we've used an efficient 1.1 U value glass in the eastern facade to create these diamond panels, we have used sage glass in the western and the northern facade as well, because in these areas you will see at in some months, in some hours, even the northern light has a lot of glare. So we've used sage glass in the northern edge as well of the building. And you can see in the left image, you start to see the triangular piece of the reception, which is again a complete glass building with the roof too being sage glass. Why we've used sage glass again in the roof is because otherwise the heat gain would be too much during the afternoons into the reception area. These are some of the other views of the building. That's a view of the reception, and you can see the glass panels on the roof as well, and the kind of light and shadow that is created once you enter the building. And the beauty of the reception is that walking into the reception is that this entire diamond edge of the building, you never lose sight of it, because while you walk in, you keep looking at it, and when you walk into the reception as well and you look up, you can, through the reception glazing, the roof of the reception, keep looking at the entire facade. So this is an image which shows the kind of look and feel and the eastern facade of the building, the way it kind of looks to the visitor. So you're kind of awestruck by the beauty of the eastern facade and the diamond panels. That's a night view. That's a view of the western glazing. So unlike the earlier project where we've judiciously used glass only in the eastern facade, in this building, because of the typology of the client and the requirements of the client, we've got all out to use glazing all around the building. However, we've decided on what kind of glazing and how the glazing has to be used, so that the right usage is done for the glass in different areas and different locations of the building. So as you can see here as well on the layout on the left, the western edge again has been blocked off with the same planning principles of having the staircase and the lift core. The western facade and the southern edge. The southern edge, if you can see my cursor, are the washrooms, and these are dead walls. So while we've taken the eastern and the western and the northern facade as full glazing, the part of the southwest edge and the southern edge have been blocked off with utilities which do not require glazing to be taken. And here, to continue the look and feel of the entire glazing and the gray look and feel, we have taken steel panels on the southern and the western side. Sorry, aluminium panels, steel gray aluminium panels on the southwest facade and the southern facade. Again in diamond shape, so you can see on the where my cursor is on the bottom right hand side, the images that you see, and the right hand view that you can see. It continues the aesthetics of the diamond panels of the glass. However, these are aluminium panels cut in the similar diamond pattern of two triangles joined to form larger diamonds, so that the aesthetics of the building facades all around is carried forward. So this slide actually shows how we have gone ahead, and it's not been easy. There have been transportation issues of these diamond panels. We've had to do a lot of mock-ups, and when you do such complicated glazing utilities and utilization of glass and glass facades, mock-ups become extremely important, because you need to know how and what size panels to take, what is possible for the manufacturer to fabricate, what the framing structure, etc., should be. And of course, again, transportation is a consideration, because these panels had to be made in multiple sizes and then transported. So we had to do a lot of research in trying to understand what is the most feasible and optimal way of going about it. That's a photograph of the built. So while we are still finishing certain interior aspects of the building, the facade is almost complete. So you can see the building built images. I'm also showing a couple of interior views of the buildings for you to understand how the diamond panels and the framing for them have also added to the aesthetics of the utilization of the interior spaces of the building. Yeah, so I think I've come to the end of my slotted half an hour. And I would hand it over to the organizers from here.
Right. Thank you, Shaon, for that interesting presentation. Would love to personally see this project. So the building is now occupied, or it's under construction still?
The interior, the finer touches for the interiors is right now ongoing. So it is
Right,
not yet
right.
occupied, but it would be occupied very soon. It's almost
Okay,
complete.
great. And it's Monte Carlo's own building, right? So they're going to
Own
occupy with
corporate
their
office.
employees, or it's also going to be leased out to other customers.
No, no, it is for captive use of the client themselves, corporate office, which is why they wanted, that's why the stress on iconicity.
Right, right, right. Great. So actually, in one of the earlier webinars, we had so these triangle panels which you showed actually are operable panels. So they open out, and we had one of the component manufacturers who supplied for this project showing us a mock-up of how the triangle panels open out for in case if there is smoke or if there is fire, for the smoke to go out.
Right.
Beautiful. Showed a video of how those triangle panels open out and close in, with the help of actuators. So good to know about the design inspiration of this project. Great. So Shaon, there are a few questions. We'll take this after Galen's presentation. We'll move right ahead to Galen now. So Galen, it's your turn now. I can see your footer also. If you can hide the footer. Right, right.
Better?
And are you on full screen?
I think so. Can you see my full screen?
I can see the full screen, but I can see your dock also. Can you just move to the next slide and see? I can see your header also.
Uh,
Can you just go to the next slide? Yeah, it's fine now. It's fine now. Go ahead.
okay, great. Well, good afternoon, everyone, and thanks for joining today, and thanks for WFM Media for hosting us, and Shaon for her excellent presentation. She showed some fantastic architecture and how high performance glazing can be used to benefit the architecture. I'm going to go into a bit more detail specifically on smart glass and how it can be used to design for occupant comfort and also optimum space color inside the building. So we're going to do that using this general overview that you see on the slide here. The first is, what is smart glass and how is it being used to promote occupant comfort and employee satisfaction? The second thing we're going to talk about is why space color is important for workplace environments and how smart glass contributes to space color and natural views to the outside. And then the third thing is we'll talk about the synergies between smart glass and interior LED lighting for best possible space color. And then I'm excited to share with you what we think is the next generation of smart glass. So the first question is, why use smart glass? So let's talk about the problem statement first. We know that daylight and views are a key ingredient to a successful occupant experience, right? After all, we spend about 90% of our lives inside. That was before COVID. It's probably even more now. So we have this, fundamental need to be connected to the outside. And yet, introducing daylight and views without consideration for glare and thermal comfort often leads to the exact opposite. Windows that are covered with blinds or shades, which eliminates all the benefits that were originally intended. Fortunately, there is a better way. So ViewSmart Glass automatically adjusts tint based on the time of the day, sun angles, local climate data, and occupant preferences to balance daylight, views, and comfort and energy performance. Let me play that one more time. So here you see the glass transitioning from a tinted state to a clear state with the New York City skyline in the background. But note that views are maintained regardless of what tint state the windows were in. But just to be clear, there's more to the product than just the dynamically tinting windows. It's actually a combination of the three things you see here. There's the smart glass itself, which is a high performance insulated window with an electrochromic coating that dynamically tints to optimize daylight, glare, and heat control. And then there's the network which is the low voltage power and data infrastructure that connects all the windows together and enables many future IoT applications that we'll have to talk about on another webinar. And then there's the software component, which encompasses, the predictive control algorithm that ensures the windows are always in the correct tint state at the correct time. But just keep in mind, this is completely flexible, it's customizable, it's cloud connected, and it's able to grow and adapt throughout the life of the building. So next, I wanted to address 3 of the reasons why I think smart windows are seeing widespread adoption in the market. The first is the most obvious benefit, but not necessarily the most impactful for occupants, which is energy. So this slide shows what we typically see in terms of peak cooling load savings and annual energy savings on account of using smart glass. Obviously, this will depend on the climate and the building type, but this gives you a sense for what we're often seeing. So maybe 14% savings on the peak cooling load side, and somewhere around 6% on an annual energy savings. One of the most important things I think about, leveraging smart glass in the building, though, is simply by eliminating the blinds in your building, occupants can enjoy unobstructed views to the outside, and most importantly, they're comfortable views that are absent of glare. And when you provide thermal and visual comfort to these occupants, even right next to the glass, they're more productive and satisfied. And if you're a building owner and developer, you can realize more efficient space utilization because occupants are comfortable right up against the windows. So this becomes important, I think, in this post-COVID world where we need to have, social distancing within our buildings. And so we need to be able to use our spaces more efficiently and allow occupants to be located right up against the windows. And then last but not least are the health benefits that I think largely stem from simply providing those unobstructed views to the outside and keeping occupants comfortable. So this was a study conducted by Professor Alan Hedge at Cornell University, where he found that occupants working behind view dynamic glass experience about 50% reduction in eye strain, 60% reduction in headaches, and a 56% reduction in drowsiness, simply because they had those views to the outside and were comfortable. So really interesting results that we're seeing on the health side, which again is only going to become more important in this post-COVID world. So that's a little bit of a background on the product and why we're seeing adoption in the marketplace. But next I want to just talk about the primary topic of this webinar, which is designing for optimum space color using smart glass. So first let's talk about why color matters. So color is an important feature for many reasons. Sometimes you may want to express color, very deliberately in your architecture. Sometimes you may simply want to present colors in an understated yet natural manner. But as it relates to views to the outside, you want to present them in the most natural way possible. So those views outside are rendered in an unbiased color and presented in a manner that you would expect. Then there's the synergies with electric lighting. So how daylight and electric lighting interact to either promote contrast, visual contrast in the space, or maybe they complement each other. That's sort of a choice that designers have to make. But certainly what one of the primary goals of color and space is to render the people in the space as naturally as possible. So whether it's rendering the faces of the occupants or the clothing, obviously very important design consideration. And also for the interior architects, they want to render the interior finishes as naturally possible. If you specify a certain carpet color, you want the color to be represented authentically and naturally. And then these last 2 pieces, circadian stimulus, mood, emotion, and atmosphere are also things that can be affected by space color. These are topics of probably another webinar altogether, so we're not going to address them here today, but I just wanted to bring them up as other factors for why color matters in a space. But now that we've discussed a few of the reasons why color is important for architectural lighting, let's discuss how we characterize color. So there are three primary metrics we use to describe color of light in an architectural space, whether it's from daylight or electric lighting. The first one is color temperature. That kind of describes the hue, or rather the warmth or the coolness of the light. So a high color temperature above 5,000 Kelvin is usually associated with cool or somewhat bluish light. And color temperatures below 3,000 Kelvin are considered kind of warm tones of light. Okay, so we'll just keep that in mind. The second metric is color fidelity, and some of you may be more familiar with the color rendering index. This describes the color shift or rendition associated with light, as indicated by the middle photo here. How accurately are those colors represented by the light? It's a scale of 0 to 100. And then the third metric is color gamut, and that describes how saturated the color of the light is. Okay. So next, I just wanted to talk about sort of two basic principles before we start looking at outcomes. The first is that light is additive, both in terms of color and intensity. So this becomes important when we start to discuss how daylight and electric lighting come together to achieve desired outcomes for both color and light levels. So as you can see here, if you mix light sources of three different colors or more, when you add them all together, you're eventually going to come up with white light. Okay. And also similarly, if you add different light sources together, they actually add linearly. Okay, as indicated in the diagram on the right side. So we'll keep that in mind as one of our basic ground rules. The second principle is that spectrum is fundamental building block for light. So just like DNA in our body is sort of the fundamental building block for what describes us as a person, whether it's our eye color, our hair color, skin color, height, etc. The spectrum of a light source does the same thing for light. It describes the intensity, the composition of the light, whether it's in terms of ultraviolet, visible, or heat. And more pertinent to this topic on this webinar is the color. The color temperature, the color fidelity, and the color gamut all arise from the spectrum of the light source, as you see here. And that ranges in the visible spectrum from blue on the left, blue wavelengths on the left, towards the red wavelengths on the right. So when we characterize color in a space, we use industry accepted calculators from the IES and ANSI, where you basically plug in the spectrum into a calculator and it processes the data and produces the three metrics that we talked about: color temperature, color fidelity, and color gamut. So let's show some examples of how this comes into practice. So again, with ViewSmart glass, we have these varying tint states, right? So with our tint 1, we allow 50% of the light to come in, and all the way down to the darkest tint state, tint 4, on the right-hand side, we only allow 1% of the light transmission to come in order to control glare. So daylight through dynamic glass is highly variable, and it depends on the time of the day, the sky condition, and what tint state it is. So this slide shows 4 different tint states of the window and the resulting light levels and the spectrum and color that would be achieved in the space from daylight alone. Now in the 2 clearest tint states on the left, an abundance of daylight is introduced in the space, well over 1,000 lux. And the spectrum and color of the light almost perfectly matches that of exterior daylight because the transmission through the windows is perfectly neutral. Now in the 2 darkest tint states, tint 3 and 4 on the right, you can begin to see a shift towards the blue spectrum. Okay, this is sort of has been a natural consequence of electrochromic glazing or smart windows. However, you will note that the light levels in these 2 tint states are below the typical threshold of 400 lux, which is typical for office lighting. So this is the natural consequence of reducing the light transmission to control glare. So we know electric lighting, the interior electric lighting, will be on in these cases to provide the desired light levels, just as they would be if you were to close blinds in response to glare control. You're going to have interior lighting on in those cases to increase the light levels in the space. So let's see what happens when you do that. As shown on the right two images, the interior lighting completely dominates both the spectrum and the color in the space. And this is due to the additive nature of light that I mentioned previously. When you add the spectrum of daylight and the spectrum of interior electric lighting together, the result will be biased towards whichever light source has the higher intensity, in this case, the interior lighting. So you can see the color of the light completely changes to match basically whatever the electric lighting is designed for. And the spectrum kind of aligns as such as well. So this is kind of how electric lighting and dynamic glazing have always worked together to achieve optimum space color, in some sense, regardless of how blue the electrochromic glazing becomes in its darkest tint state. And this photo shows a real-world example of what I just described. So here, the windows are in tint 4, the darkest tint state to control glare. And I'm sure it's obvious to all of you that the windows are clearly biased towards blue. However, notice the people in the room. Their faces and their clothing are completely neutral in color, unbiased by the color of the blue windows. And why is that? Well, it's because the space color is dictated by the combination of daylight and interior electric lighting. And when you're controlling for glare with smart windows, so little light is being transmitted that the electric lighting tends to dictate the color in the space. Okay, and that's how we achieve perfect light quality in the space, regardless of what tint state the windows are in, and regardless of the bias towards the blue that you see in the windows. Now, I want to point out two final things here. The first is that even though we're controlling for glare with only a 1% light transmission through those windows, the views through those windows remain completely unobstructed, right? You can still see to the outside remarkably clearly, which is more than we can say for the alternative glare control solutions such as blinds. So this is a great outcome. Now, the second thing is, I know what all the architects are probably saying right now. I still would prefer a window to be less blue, right? Let's not kid ourselves. All the architects out there prefer to have more neutral tinted color. So don't worry, I'm going to come back to that later on. So the last question I wanted to kind of discuss or answer here is what type of LED lighting should I use for best color in the space, given some of the things that we just talked about? So we've done some studies in this topic, and we have some white papers on our website that go into far more detail. But I wanted to give you just a quick study that shows how we might respond to that. So I'm looking at 3 different LED types of 3 different color temperatures. A 3000 Kelvin, kind of a warm LED light source, a 4000 Kelvin, kind of neutral LED source, neutral in color, and then a 5000 Kelvin on the right, which is more of a cooler, almost blue light source for LEDs. And you can see how the spectrum of those LEDs compares to our spectrum, the view spectrum in our darkest tint state. You can see how there's some potential for complementing one another right away across the spectrum. So in order to study that, I looked at a south-facing office in Washington, D.C. over the course of the year. And I averaged all of the daylight illuminance levels in the space throughout the year when our glass is in its darkest tint state in tint 4. And you can see that illuminance profile on the right-hand side in the blue line, where it shows the light levels as a function of distance from the window. And you can see that entire profile, it starts at around 2000 lux near the window and it drops off to below 100 lux in the back of the space, all of which are below the recommended illuminance target for an office space, which is 400 lux. So we know we need to add interior lighting to augment that, right? So once you do that, once you turn lights on in the space, now you're above your recommended light levels. And let's see what starts to happen to the spectrum and the space color in the space. So let's start with right up against the window, 2 feet from the window, you see the blue line, which is the spectrum of view glass in tint 4, which peaks in the blue wavelengths. And then you see the spectrum of the LED, which is the orange line. The black line, the black dotted line, shows what happens when you mix those two together based on their corresponding intensities. So right up against the window, it's kind of a mix between the two because there's roughly equal light levels. But as you start to step back into the space, 10 feet away, 20 feet away, 25 feet away, and so on, you see the spectrum starts to converge on that of the electric lighting source, which means the color in the space is going to match that of the electric lighting, not of the daylight. So when we look at this in terms of color, we see that despite the higher color temperatures of daylight, regardless of what color temperature you use for LED lighting, the color temperature and the color fidelity in the spaces are going to match basically whatever the electric lighting source is. So what type of LED should you use for best space color when used with View dynamic glass? I would say 3000 Kelvin to 4000 Kelvin tends to supplement View's darkest tint state the best. 3000 Kelvin achieves the best mixed color quality overall, while as 4000 Kelvin achieves the most uniform color. I always suggest a CRI or color fidelity greater than 85 to achieve the optimum space color quality. And you should avoid using LEDs that peak in the blue wavelengths because that's exactly where the darkest tint state peaks. So we don't want to compound that blue factor with the electric lighting spectrum. So look for sources that have a broad spectrum across all wavelengths, and especially with prevalence in the red wavelengths to augment where we have a lower intensity in our View tint state. But keep in mind there are other considerations that we need to keep in mind, such as aesthetic goals. Do you want to contrast the relatively cool daylight on the outside with warmer interior lighting, or do you want to try to match them? Those are two design considerations. And also what type of daylight dimming control system you have. That'll also play a factor here. So that's kind of the educational piece of how smart glass contributes to space color. Finally, I just wanted to introduce a new product that we're coming out with right now that addresses and contributes to all the things that I just talked about for achieving optimum space color. And remember, we showed the photo about blue glass, and I mentioned some of the architects may have hoped for something more neutral. That's where this product comes in. We're calling it View G4 Smart Glass. And just like our previous products, it intelligently changes tint from a clear tint state at 50% light transmission down to a darker tint state, tint 4 at a 1% light transmission, and the solar heat gain coefficient changes accordingly to control for heat gains throughout the year. All of those parameters are just the same, so we're still achieving the same performance that we always have. But now we're doing it with 3 major improvements. And the first one is the one that we talked about earlier, which is just more natural color rendition. So whereas some members of the design community, particularly architects, found the tinted color of smart glass to be rather blue, we have addressed that aggressively by making the glass more neutral in its tinted state and achieving higher color rendition qualities. And you can see that in the side-by-side photo on the left. We've also addressed glass clarity by reducing, haze that is all too common in high-performance glazings, whether it's from low-E coatings or laminates. We found a process to dramatically increase the clarity of the glass in the clear state. And then from the exterior, we've improved upon the color quality from the outside as well by reducing the yellowish or amber appearance that was sometimes seen in the clear tint state. So now that's more neutral too. But I just wanted to show a few side-by-side photos before we close here, just to give you a sense for what this means for maintaining the best possible color quality, both through the glass to the outside and also the interior color quality. So View G3 is the window you see on the left. That's our previous product, and View G4 is our new product on the right. In the clearest tint state, there really is no change. We already had perfect, neutral color quality in that tint state. It's really in the darkest tint state where we are seeing the most improvements here. So this is a view from the inside looking out. You can notice how much bluer it is on the left. and how much more neutral in color it is on the right with our new product. And that's indicated by the color metrics you see in the bottom. The color temperature is significantly lower, which means it's less blue. And also the color fidelity is also higher, 87 instead of 81. And that really becomes apparent when you start looking at colors. So this is a view looking outside into the landscape. You can see the wood chips are now rendered in more natural wood tones. That's due to the higher color fidelity and lower color temperature. And this is also important for the light that comes into the space. So this is a view inside the building. Look at objects inside your space, right up against the glass. You see the colors in the fruit bowl are now rendered much more naturally. The yellows appear more yellow, the apples are more red. Again, this is a result of the less blue in the glass and also the higher color fidelity. The best test is always the skin tones. If you hold your hand right up against the window, you see how much more naturally skin tones are rendered in the space. And we know how important this is for both occupants and for designers when they're thinking about, architectural finishes and how they're rendered, both in the clear tint state, which has always been good, but also in the darkest tint state when we're controlling for glare. You want good color quality in that tint state as well. So that's really what I wanted to show you today. I hope you come away with just a few key takeaways here. First being that View Smart Glass, we're achieving widespread market adoption, mainly by promoting employee comfort, wellness, and workplace satisfaction. We also want to point out how smart glass and interior lighting, they really work together to produce a desired space quality. And appropriate LED selection, you have some choices there, and it's ultimately going to depend on aesthetic preferences and priorities for your space. Now, aside from space color, smart glass can also have an effect on the color quality of the views to the outside, as we showed in those previous photos. And designers must choose wisely if they want a neutral color, because not all smart glazing achieves neutral color. And View G4, our new product, achieves neutral color, both on the views to the outside and the daylight introduced on the inside, and also with high color fidelity, so colors are rendered in the most natural, unbiased way possible in the tinted state, but crucially, while also preserving views and maintaining complete glare control for the occupants. Okay, folks, that's the topic I wanted to share with you today. Thank you so much for your interest and on this topic. And I believe we now have some time for questions.
Right. Thanks, Galen. Can I have Shaon also back? We'll take some questions quickly. Hi, Shaon, can you hear me?
Yeah.
Yeah, cool. Sure. We'll take questions for you first. We'll just give Galen a breather. Okay, so there's one question for you here. First one is, we just pick this up for you. Hold on just a second. Right. For the Monte Carlo project, how was the glass wastage encountered with seeing the different panel shapes? There appears to be considerable amount of glass wastage. So how economically viable is such a complicated facade from a client perspective? Such a nice complicated facade, I'm sure, would come with significant cost of glazing and materials. By Sudhir Mohan.
Yeah. So there are two things. One is that obviously it is not as cheap as a normal DGO would be, and that's not the intent, because you're looking at an iconicity of a building. So obviously there is an additional cost component vis-a-vis a generic building. But having said that, the way we reduced costs was that we actually started talking to the glazing manufacturers, the glass manufacturers, panel manufacturers, even before the building design was done. So for example, right, we would want to take the floor to floor height to say a 4 meter or sorts. We reduce the floor height to I think 3.6 meters or 3.8 meters. I'm not able to recall the exact value, but the thing is that we reduce the floor height to a height which could bring efficiency to the glass. So
Right.
that's the point where we started talking to the manufacturers. So the building envelope or building, planning of the envelope came as an afterthought after the main structure was designed. It was not so. Even the building heights and architectural design was modulated to be able to bring in efficiency for this major glass panel. And of
Right.
course, there were a lot of other, modifications done in the sense that while I've shown you just the final output, the triangulation, the angles, the framing, etc., whatever was done, the framing thicknesses, etc., there were multiple mock-ups done, and we took consent of the fabricators and manufacturers to arrive at the most optimal, given that this was the design.
Right. Okay. Another question for you. How many square meters of sage glass was used in the Monte Carlo building?
I think it was about 30,000 square foot or so, 30 to 40,000 square foot.
Okay, 30 to 40,000 square
At
foot.
that time, it was the maximum amount of sage glass used in India as a project.
Right. Okay. And there's another question on that sage glass itself. What was the U value achieved through sage glass? Was it better than the SKN series of glass?
So sage glass is not about U value. So the U value of SKN 144 is obviously better than sage glass. The intent of, so what we had done is that we had taken high U value glass, or the U value regulated glass more on the eastern facade in the diamond panels. But where it was sage glass, their U value is not the factor, because anyways it's called the visual transparency factor of sage glass is important. So their visual transparency reduces from a 60% to a 1%. So when that happens, the U value is not a consideration. In sage glass, the transparency it kind of supersedes the requirement of a better U value. And what we did was that in that entire western facade, we have not taken sage glass. The spandrel panels are not sage glass. Only the visual, the glass panels are sage glass. So we've taken in the spandrel panels. So that's how the sage glass has also been reduced.
Okay, right. So I'll take this couple of questions for Galen. Galen, can I have your camera on back?
Oh, sure.
Right. So Galen, the question for you is there any secret recipe in View G4 glass? Even though at 1% VLT, you are able to maintain pristine natural light. Can you throw some light on that?
Yeah, absolutely. So let me pull up this slide here. So that is a key value proposition for our smart glass. Is we want to balance views to the outside with comfort and heat control, right? And so, we're tinting the glass down to 1%. Even we can go down to as low as a 0.5% light transmission to control glare. So really, it's just darkening the glass, but it's not obscuring the views in any manner. It's providing still an unobstructed view to the outside. So it's really just think about dark tinted glass. You can still see through it, but it's dark enough that it's controlling for glare from the direct sunlight, and that's an important factor to consider. I also just to the previous question, I wanted to point out the U value feature. You can see the U value at the bottom of this slide for our standard product, but we can also do not just double glazings, but we can do triple glazings, and we can add additional low E coatings to other surfaces to achieve even lower U values if that's desired.
Right. And actually the next question was that is the glass available only in single pane or double pane? But you in fact answered it that you can also get it in triple pane, correct?
Correct. And just to be clear, we never are applied to just a single pane of glass. The electrochromic coating has to be concealed within at least a double pane unit to protect the coating from damage. So it's always within either a double or a triple pane glazing.
Okay, right. Shaon, for you, this question. In the MNRE building, solar panels are installed on the entire south facade. What type of solar panels are used?
So because the efficiency type, meaning this it matters, the efficiency matters. So in India, typically we get solar panels with an efficiency of 17 to 18%. However, we have taken high efficiency solar panels to the tune of 20-21% because of the surface area that we have. I mean, we've been able to cantilever the roof surface to a certain extent, but beyond that, there is no other space in the building to increase the solar extent. And the southern facade essentially is not a very efficient methodology of, while we have taken solar panels on the southern facade because we really didn't have a choice because there was no other area where a solar panel can be taken. But normal solar panels taken on the southern facade, you see what happens is that they all come at an angle. So one throws a certain amount of shadow on the next one, do what? At least at certain times of the day or certain times of the year. So the efficiency of solar panels on a vertical facade, normal solar panels is not very high. So it is not really advisable to take it on a vertical surface. You should definitely take it as max as possible on a horizontal surface. We have taken it on the south wall because we were at a tipping point of the net zero thing, and we really wanted some more solar generation, but it's not the best location to take if you do get a horizontal surface, because it's far more efficient to take on a horizontal surface.
Right. Sticking on the same project, there's a question which asks, how are you then addressing the issue of facade maintenance and cleaning? Considering there are solar panels on the roof as well as on the facade. So how is that taken care of?
So we have inbuilt mechanisms and systems for the cleaning, and that again is designed from day one. We have a complete grid system and cleaning system design, and the framework is there in place to be able to access each and every solar panel and clean them. Because unless you clean them, there's no point putting a solar panel. You have to clean them, and you have to have BMU systems for the verticals, and you have to have various other cleaning methodologies for the horizontal surfaces, and which is also something which brings down the efficiency, because these equipment's cleaning methodologies also need rails, and so you have to do a complete detailed laying out these equipments to finally find out how much is the solar output or the final solar surface that you are getting, because these equipments also do take some amount of
Right.
space.
Right. I'll take, we've got 2 more minutes.
It's not only about the cleaning system.
Yeah.
It is also, when you do have a solar panel of this kind, there is a supporting system, there's a structural system. So a lot of times it happens that you have verticals that go up, and then there are, trusses pulling that entire support system below. So then they also throw shadow onto the solar panel. So you have to do a detailed simulation and study. We've done the simulation for the solar roof at least about 10 times by now through the detailed designing phase, to see that with every addition we are not flouting the requirement of the solar output for the project.
Right. Okay. We have 2 more minutes, so I'll take a few questions for Galen now. Galen, what are the glass shade colors available in view?
Right. So our standard product uses clear glass panels on both lights of the IGU. We think that typically results in the best appearance and color on the inside and the outside. And then of course the tint, as you see on this slide, from tint 1, our clearest state, to tint 4 in our darkest state, there's a transition from clear to slightly darker, but across that spectrum it's quite neutral in color. So we do offer other color options for our inboard light, the glass panel on the inside of the double glazing unit, whether it's solar blue or green or bronze or whatever the case may be. There are some options there for the architects if they want to see different body tints for the window itself. But that's not very common. Most designers tend to prefer just a clear glass product that presents, the appearance of the building and the color in the inside in the most neutral way possible.
Right. Okay. Shaon, a question for you. What's the current status of the MNRE building? Is it under construction or is it completed or what?
It is the structure is about 80% complete.
Okay, and sticking on that, the same person has asked, considering this has to be a net zero building and it should have the best possible glazing, why wasn't dynamic glazing considered on that project?
Why wasn't what was considered?
Dynamic glazing, your electrochromic glass, your dynamic glass. Why was it not considered on the MNRE building?
So essentially, the cost considerations are, of course, there. However, what in MNRE, our process, because it was a government building, we tried to achieve net zero more by passive methodologies than active methodologies. I mean, it's easy to get net zero building by bringing in extremely efficient equipments. You take expensive glass, and you pump in a lot of initial cost, and you're able to get net zero. But that was not the intent, because it is a Government of India building, a showcase building, something which would go on to turn out as an example for the common man to kind of take the ethos out of it and take it forward. We tried to stick to more passive methodologies instead of cost intensive active methodologies.
Right. Okay. I think we are more or less done today. I'd like to just a second. Give me a second. Right. I am just changing. Right. I just wanted to thank our speakers for today, Shaon Sengupta from Edifice and Galen Burrell from View Dynamic Glass, for taking time out and enlightening us with this interesting presentation. Just to our audience, thank you for attending. This webinar was recorded, so 2 hours after we end this webinar, this recording will reach your email inbox. In case if you're not able to click the link over there, you can visit our website webinars.wfmmedia.com tomorrow, and this link will be updated on our website. So thank you all for attending today's session. I know there are a few more questions, but in the paucity of time, I wouldn't want to be taking them. I'll pass them on to the speakers, and they'll probably respond to you at their convenience. So thank you all. So thank you, Shaon. Thank you, Galen.
Thank you so much. It was a pleasure.
Thank you so much, Ahad.
Thanks,
everybody.
For that interesting presentation. So all of you, please stay at home, stay safe. I hope together we can overcome this pandemic and return to normalcy soon. Take care. Bye-bye.
Thank you.
So long.
Bye-bye.
Thank you, everybody.